So, hello everyone. In this part of the video, we'll be integrating with the front-end code. So now let's go on with it. So we have opened our terminal and now let's go on creating our front-end folder. So we'll give a command in the terminal as npx create next app at latest and we'll name it as front-end. Now this will create front. This will ask us now. I'll just go on customizing the settings. So we want TypeScript. We'd also like to use our ESLint. We also want our Tailwind CSS. So also our app router. So it has started installing our all dependencies. So first let us understand what was Tailwind CSS. It's a utility first CSS framework that will let you allow the style elements using the small case class names directly in your JSX. It can to speed up the UI development and will remove all the need to write all the custom CSS files. Then we also have ESLint, which is a tool that checks that the JavaScript or the TypeScript code for errors and enforces the consistent coding standards. Then we also selected for an app router, that is the new routing system in Next.js that just uses the app directory with layout, nested routes, and the server components. It just improves the performance and simplifies how pages and the shared UI are handled. Then we have also imported alias, so which is a shortcut that replaces a long relative path with the clean readable imports using symbols like @/ Then we have like in this import alias also makes large projects easier. So we can see here it has added all the required packages. You can see here success created frontend and the address where it's created. Now I'll just close the contact and share frontend folder. You can see all of the files here in this. So let's go on understanding briefly what are all those files. So we have package. Before we understand this, we'll also install the dependencies that we require, like additional dependencies. So we'll have npm install. It will require RainbowKit. Will be that RainbowKit. Also, we want React query. Then we have access theme and also the Wagmi. So we actually want this additional dependencies for our project to run well. So we are just installing the RainbowKit, like stack and this. So let's install this. So let this happen till the time we'll understand. So we have package JSON. So what is package? So package.json just defines the project metadata, dependencies, and the script, like example dev, build, start. So this all comes under package.json. Then we have nextconfig.js, nextconfig.cs here, which is a configuration file for custom settings like redirectories or envs. Then we have our .get ignore. So you can see .get ignore here. So this specifies files and folders to exclude from the Git tracking. Also, we have readme.md, which is basic instructions and documentation for your Next.js app. Then we also have a public folder in which we have all of these files in it. So just store all the static, like images, icons, or robots.txt, and all of those just served directly by the app. Then we have SRC app, which is basically a core app directory that uses the app router. We also have favicon.ico, the default site icon shown in the browser tab. Then we also have layout.css. Then also we have node modules. There are lot of node modules that are auto-generated. So these are the installed packages and dependencies. So our installation isn't yet complete. So as of now, we have installed all the required dependencies. Now let's go on writing our front-end code. So in our front-end folder in SRC, we'll create one more folder and we'll name it as LIP directories, and inside that we'll create a file and name it as wagmi.ts. And now we'll write all the wagmi.ts code here in this. So first we have import, and in that we'll write get config, and then we'll import this from our RainbowKit. So we are just imports the RainbowKit helper function, like for generating a default wallet configuration. So this config is used by Wagmi plus RainbowKit to just enable the wallet connections. Then we'll import define chain. I'll import define chain and we'll import it from Beam. So yeah. Then this will import a utility from Veeam that lets you define a custom blockchain network. Now let's go on exporting. So export const rootstock testnet, rootstock testnet, and that will be the defined chain. So this will define a custom chain object for a rootstock testnet. Now we'll give our ID as 31 just because we want testnet. For minute, we would have given the ID to be as 30. Then we'll give it a name and we'll name it as rootstock test. Then we'll give the network. So our network will also name it as rootstock testnet. So network will be rootstock testnet. Then we'll now give the native currency. So here this network slug is used internally by Wagmi or VM. Now let's give native currency. So native currency, this will give the decimals as 18 as the number of decimals the native token uses. So that's what we give. Then we'll give the name to it. So the full name of the rootstock testnet currency, that's a test smart Bitcoin. So we'll give that name to it as test smart Bitcoin. Then we'll give the symbol of test. So that is TRBTCs. Then we'll give our RPC URL list. So we'll just enter here and we will write RPC URL list. So RPC URL list and here will so this RPC endpoints the app that will use to connect to the rootstock testnet. So now I'll give default HTTP and the primary RPC URL will write in this that is HTTPS public node dot test. Then we'll give the public. So public will write a public RPC URL. So similarly we'll get HTTP here, and then inside this we'll be mentioning our complete URL. The same URL will be pasting it because we want the same endpoint that is used as a fallback. So we'll be copying this same here and this. Well, perfect. So now as this is done, we'll now give as Block Explorer. This will be a configuration for showing the links to Blockchain Explorer. So Blockchain Explorer. So here in this Blockchain Explorer, similarly, we'll give the default first. So default, and inside this, we'll give the name and the URL. So name We'll give it as Rootstock testnet explorer, or we'll just give RSK testnet explorer, and the URL https explorer.testnet.rsk. So here this explorer where the users can view the transaction, the blocks, and the contact info. So we'll just end this here. And now we'll give our testnet.to. So here this will mark this chain as a testnet, which is important for wallets to show the warnings. And here we end this export. Now we'll open another export and we'll as export config that would be equal to get default config. So this will create the main configuration object for Wagmi as well as the RainbowKit. Now we'll give app name. So we'll give name and we'll name it as IPFS file storage. IPFS file storage, and then we'll give our project ID to it. Process.pnv underscore public wallet connect. We'll give it as, and we'll mention our project ID here in this. So this project ID will be connected from Wallet Connect. So whatever after going to Wallet Connect website and logging there, whatever the project ID will get, we'll just paste it there. Now, so this have loaded from the environment variables. This falls back to a placeholder if missing. Now we'll go change, and inside that we'll write the Rootstock testnet. So these are the registers. This confirm Rootstock testnet chain that is defined above. So whatever we have defined above, we have just registered it. Then we have this is our true. This will just enable the server side rendering or compatibility for Next.js app router. So here we have just completed writing our complete. Now let's move forward and go on writing our layout.tsx. So just it's auto generated. So we'll just update this completely and let's just start writing our own layout.tsx. So we'll give it import first. So import type and we'll have the metadata in it. Metadata. I will take this metadata from next. So this will imports the metadata type from Next and to like strongly type the metadata object. Then we'll give another import and we'll give it as enter. And this will be from or next font Google. Now we'll import the global.css file. Here in this import enter, like this imports the entire font loader from Next.js. This is automatically optimizes the Google fonts which have been there. Then let's import our global.csx, global.csx, and this will import it from providers. Then I will give const enter that will be equal to enter and we'll get the subsets to it. And so this will have Latin, So this have simply just loads the entire font with the Latin subset and returns a class name for stylus. So as we have done that, let's close this. So now metadata, I will give the metadata here. Metadata that would be equal to, and we'll give the title here, IPFS files storage map. And so this will like title our, so this will just title of our application that will be auto injected into the head. Now we'll give the description and we'll give the description as decentralized file storage on Rootstock with IPFS integration. Decentralized file storage on Rootstock with IPFS integration, and we'll just end this here and again give an export default function root layout. So in this we'll give children, and we'll just give a semicolon, and inside this we'll be writing as child, we'll be writing as children, that will be equal to react node. So what will this do? So this will is a root layout is the main layout wrapper for the entire Next.js app route application. So every page component is rendered inside this layout. So now I'll just give a return. Inside this we'll give our HTML tag. So we'll just begin our HTML from now. So HTML language that would be equal and so this will set the language attribute for accessibility and the CEO. Then let's give the body and name that body as class name, that would be equal to enter dot class name. So this will just applies the interfont styling to the entire page. Now we'll give providers, and inside providers we'll just write children and close the providers tag, body tag, and HTML tag accordingly. So we have done with our complete layout.tsx. Now let's go on doing our providers.tsx. So in SRC app, just go in here and create one file and name this file as providers. So let's go on writing our code of this. So we'll just we have created the providers now. So we'll begin this with use client. So this just marks this file as a client component in Next.js app router. It's required because Wagmi, RainbowKit, and React query depends on client-side features. Now, after this, we'll be importing. So import the query client, query client, query client provider, and we'll take this from stack from @stack and React query. So this will just import the React query client that manages caching, rotation, and async states. This query client provider will make the React query available to our entire application. Then we'll give import Wagmi provider, and we'll import this from Wagmi itself. Now we'll import the RainbowKit provider. This Wagmi provider will set up the Wagmi Web3 configuration for blockchain interaction. Then importing our RainbowKit provider, and we'll import this from RainbowMe/RainbowKit. So this will, like a RainbowKit provider, enables wallet UI components such as the connect models. Then we'll be importing the config. So import config, and we'll import this from library Wagmi, the file that we have created in this here in library the Wagmi.tss. So we'll just import the config from there. So import a custom Wagmi configuration like the chains, connectors, transports. Then we'll be importing import at RainbowKit and style.css. So this will import the default RainbowKit styles, so the wallet UI components render correctly. So RainbowKit on the style that now will be create a const query client that would be equal a new query client. New query client. So this will create a new React query client that instances to manage caching and request. Then we'll be importing function named as providers. Inside this, we'll give children, and so children react node. So this provider component wraps the entire app with the essential global providers. Inside this, we'll give a first tag to it as Wagmi provider config is equal to config, and then inside this we'll give the query client provider client that's equal to query client. So this will provide the React query context for API caching and state management. Inside this, and this will have our RainbowKit provider, and this RainbowKit provider enables the RainbowKit wallet UI and injects wallet connection models. Inside we'll write children. So this renders all the child components inside this global providers. Right? So here we are done writing our complete provider.tsx files. Now let's go on main page.tsx. This is auto-generated. We'll write our own. We'll edit it at this all, and we'll start writing it. So this will give the main page for us. The website will open and show all this from this page.tsx itself. So first we'll give use client. As you know, use client just marks this component as a client component that's actually required for hooks and wallet providers. And we'll give import use state and use effect. And we'll take this all from React. So this React hooks for state and lifestyle logic. Then we'll again give import, and we'll inside this we'll give connect button from our Rainbow. So this will like RainbowKit UI button will be generated to connect the wallets. Use account, then use write contract, then we can use use wait for transaction receipt. So we are just creating the Wagmi for transaction receipt, and we'll use read contract, and we'll take all this from Wagmi. So this has simply just it's all our Wagmi hooks for managing account, for writing the contracts, for transaction receipts, and for running the contract as well. Then again, we'll give import, and we'll give XCS here. We have already downloaded it while downloading the dependencies. XCS, then we'll give your const API. So we'll just mention this API key will be generated once we deploy it. So the full API will be added after deploying the smart contract. So just keep this empty, and then give as const. Now we'll give const and the contract address. So you just need to enter the contract address here by 0, to 0 and the complete contract address here in this. This will be the contract address once you deploy a smart contract. Whatever the address will be there, you just have to paste the address here as const. Then we have our Pinata gateway to serve IPFS files. So for this, we'll give con Pinata gateway. This will be equal to process dot env dot next public Pinata gateway Pinata. Next public Pinata gateway. Gateway is the link. So from this we can just get our Pinata's public key. Then we'll give some utility functions for format file size. So on format file size that would be equal to byte colon number, and then we'll give it as string that would be equal to, and inside this we'll write if the byte, so it will check now byte is 0, it will return 0 byte. Return 0 byte. Then we'll give const k that is equal to 1024 bytes, 1024. Then const sizes that will be equal to bytes, kb, mbg. So our sizes that will be displayed in this format. Like we can get bytes as well as I can get in kb, in mb, as well as in gb. Then we'll give const I that would be equal to math dot, I will give, and then sorry, we'll give maths dot log bytes. So we'll get all our bytes. We'll be doing maths log, maths dot log. Now this will return as load bytes maths, and then we'll give you a power function maths dot pov, and we'll have comma I, so that will be a base and index. Then we'll give dot to fixed. Inside this we'll give 2 plus, and we'll give colons, and we'll just give a space in it, and we'll add the sizes of I, whatever the size of I will be. We'll give the sizes, and that it will give I. Now we'll just give another utility function for converting Unix timestamp to readable date. Format date that would be equal to the timestamp. This will have a big int as it will be a big integer. Then this will give the return new date, and the new date inside will give number and the timestamp into 1000, and dot to local date string. So to local date string will given this slash US comma, and now we'll give, so year, and this will give numeric, so you want years to be numeric. Then month, that will be short. Then we have day, that would also be numeric. Then we'll give, just a second, I will give R that we want as a 2-digit, and finally a minute also 2-digit. So that's it. We have just done with this cons. Now we'll give a function to upload a file to Pinata, that's an IPFS. So we'll create a const again, const, and we'll give it as upload to IPFS. That will be an async. Inside this we'll give file, then on progress, and we'll give the percentage colon number, that would be in void. Then we'll give promise string promise. This will also take us like, now here we'll be creating a form submission payload. So for this we'll write const form data that's equal to new form data, and then form data dot append inside this will give file, and I'll just get our file in this. Then we'll give again form data dot append, and then now we'll give the Pinata metadata to this. So we'll write Pinata metadata, and we'll just give a JSON. So JSON IPFS string. Then we'll just give the name. Then again dot string IPFS, and here we'll give the CID version to it. So CID version, that's 0. Now we'll give another const response. Const response will be equal to await access dot post. So this is just making a post request to Pinata's pin file IPFS API. So post, and we open it here, we get HTTPS, and I'll just give the complete link to our API Pinata cloud. API dot Pinata dot cloud slash pinning slash pin file to APS. Pin file to IPFS. And then again we'll give form data. Inside this we'll give the headers now, and we'll give the content type. Content type, that would be a multi-part form data. So we'll just mention it here, multi slash form hyphen data. And then we'll give the Pinata's API key and the Pinata secret API key. So there are two keys generated in Pinata. One is their API key and the other one is their private. So one is the same. Process dot public Pinata API key. Similarly, we'll give it also for a secret API key. Secret API key. That would also be given as process dot next public dot next public Pinata secret key. We'll just track the upload progress event. So for that, we'll give on upload progress, and we'll write the progress event, and we'll give the if statement here. So if on progress, and we'll give a logical operator. And so if on progress and the progress event on progress, and math round dot round, that will have progress event into 100, the progress event dot total. Progress event dot total. So this logical operator will just check if this both on progress and the progress event dot total goes hand in hand. Now we'll give the return the IPFS hash. So we'll give return dot return, and we'll give response dot hash IPFS hash. Sorry, I have give this return. Yep, after this. Now we'll write the main component, that's export. So we'll be writing as export default function home, and in this we'll give the cons, the address, and is connected. So we'll just give the wallet address plus the connection status to us. This will be equal to from the user account. So whichever the account has been used, it will just mention its wallet address on the whatever the connection status is. Then again on div cons, so we'll be giving the selected file and the set selected file. So we'll create local states for storing file input, for uploading the progress, for errors. So as we'll go on, so selected file and then set selected file. This would be equal to use state and has to be less than the file. This will give null greater than. Again, we'll give const. Now here we'll be stating it for uploading the progress, upload progress, and set upload progress, set upload progress. Similarly, we'll give this as use state number that is given as 0 is initialized to 0. Then another const for uploading. So is uploading. Set is uploading. So we'll set it. Set is uploading. Is uploading. This would be equal to our use state false. Another const for user files. How? Okay, here this will get the user file and we'll just set the user files. This will also be equal to use state and then this will give any and this again an empty square bracket and finally we'll give another const for our errors. So error set error and this would be equal to use state and string just give it empty. Now we write a smart contract to write the hooks. So now first let's create a hook for uploading the files to write the contract. So we'll give it as write contract. Then upload for this write contract, we'll like upload file. Then we have data. So for data we'll upload IPFS, we'll upload hash, upload then is pending will be giving us is upload pending. And this will be equal to use write contract. Use write contract. Now again we'll give const and now it will be for like waiting for the transaction receipt after uploading. So for that we'll give it const is loading and we'll give it as is upload or confirming. Then is success and we will have upload success. Upload success. And this would be equal to our wait for transaction receipt and just to give the hash as a delete hash. We'll have a smart contract for reading the another hooks like get list of users file IDs or to get metadata for all file IDs, then want to refetch any file, so we'll get refetch file ID, then this would be equal to our use read contract. And this will give the address and there is a contract address. Then we'll give our API, then the function name as get user, then we'll have arguments like arg as an address here, address, let's undefined. If we get an error, it will be displaying undefined, then query enabled address. Now we'll write another hook for getting the metadata for all the file IDs. Data, files, data, then again refetch files, or use read contact. Similarly, I also will give this same, just will change some things from here. So here we'll give address API will be same. The name of the function will be get files and here also here we'll give file IDs. Similarly here also an address will mention file IDs that will be undefined. In query we'll be giving it as enabled. Instead of address, we'll give file address, and here we'll be mentioning an and operator. We'll give another condition as file IDs as any, and we'll mention its length that has to be greater than 0. So we'll check this both condition. Now let's go on using a use effect. So this will update all the local lists when the contract file data is changes. So for that we give our use effect, use effect, and we'll again give a if files data and logical operator array dot is array, and inside we'll give files data, then set user files files dot files data dot, and then we'll be filtering those files. So for that we have filter and then file, and then we'll give this file exists. Then we'll just mention our files data here. Now again we'll use effect. So use effect. So here, so this will be for refreshing the data, like after there's a successful uploading, it will just refresh all of the data. So this will give upload success. Then refresh file IDs. Then it will also refresh the files. It will set the selected file, and inside it will give the null. And it will set the upload progress, give it to 0. Then we'll in this will give upload success, the refresh file IDs and the refresh files here. So upload success, then refresh file IDs and refresh files. Now we'll be handling the file selection. So we'll give const handle file selection, that would be equal to, we'll give it in this e, and the react dot change event, react dot change event, and you're given tag HTML input elements input. And now this here in this will give again the const file that will to e dot start. Now we'll try to restrict the file size as to be greater than 100 MB. So here again we'll give the if condition, and here the file, and using the and operator we'll give again the file size. So this both condition has to be true, that as we want this to be greater than 100 MB. So give it in this, so 100 into this, the 1024. We have given it in bytes. And if something happens, so it has to give a set error that file, if the file is greater than 100 MB, then we'll just give an error as file size exceeds 100 MB, 100 MB limit, and null, then set error, and then this will give us the error of the selected file. Now we'll give another const and we'll name it as handle upload. So this will just handle the upload including the IPFS as well as our smart contract. So handle upload, that would be equal to a string, and then we'll just give it if statement now. So if the selected file, we'll give the selected file as this. So selected file, not operator, disconnected, is connect, then it will just return try set is uploading as true, and set error, I'll just leave it blank. Now we'll give upload to IPFS. So const IPFS hash, IPFS hash that would be equal to await upload to IPFS, upload to IPFS, and inside this we'll have a selected file format set upload progress. I will just go on giving an upload file here. The upload file. So this will be store files metadata on the blockchain. So accordingly we'll give it. Inside this we'll give our address as the contract address, then the ABI, then the function name, function annual with the function name as upload file, and then this will give IPFS hash for selected file, and we'll give the begin, and so this will give the selected file size, selected file dot size. Then catch the error, so this will give set error, and the error instance of the error dot message, and it will display as message as upload failed. Upload. Now finally we'll type finally, and we'll set is uploading as hook. Now we'll give another const for handling delete. So this will handle file deletion on blockchain. So similarly, how we create this, we even have to give for const. So let's go const handle delete. This would be equal to file ID number. And similarly, we'll now give it as delete files. And inside this, we'll give this only the address, the contact address ABI, and here the file name will be delete file. And in this, we'll give just begin the file ID, begin file ID, and then this as well. And now we'll give the component UI reader. So return our first tag, PIV, division, and then we'll give the header into it. So header, so I'll just write all the header section. So we'll give the header as IPFS storage app, and we'll give this in an font. So IPFS storage app. So we'll just give this as an header to it, and then we'll give the connect button. Connect button. Then we'll just give one horizontal. Now we'll just create the main application area. So we'll give a tag as main. Inside this, we'll give is connected. So if wallet is not connected, so for that we have this is connected, and we'll again give the division. And inside this, we'll give an h2 tag, and we'll just display connect your wallet. Just give connect your wallet. Then we'll create one paragraph tag, and we'll mention please connect your wallet to start using the, and here we'll get the connect button, and here and tag will be closed. And then after this, just enter, and then just open this again. Now for if the wallet is connected, so for that we'll try it now. Division inside this will give h2 upload file. I will give the file input. So inside input will give input type is equal file on chain, that is equal to handle file select, that's equal to is uploading, is upload pending, and is upload confirming. So I'll give this 3 here in this, and I'll just close the input area. Then we'll show the file details. So we'll give selected file, and we'll just give another division tag here in this. We'll give a paragraph tag and a break. And in this, we'll be giving the name, and a little break tag will just give the selected file dot name. So selected file dot name. The paragraph tags close here. Similarly, we'll give another paragraph tag, break tag, and we'll mention here the size, and we'll give here the format file size and file size of the selected file size. Selected file dot size. And the paragraph closed our division tag. This division tag has to be closed here, which we have. And after this, we'll write upload progress bar. So for this, we'll give upload progress that has to be greater, and also the condition is that the upload progress has to be less than 100. So if these both conditions are true, and also on this we give again an AND operator to give another condition, that is the uploading. We have mentioned this in a paragraph tag, so uploading, and here we'll have the upload progress person. Now we'll give it for error or success messages that has to be displayed. So error and the style equal to color, and let's just give the color to be red. And I'll just give the error here, error, and the paragraph tag is closed here and defect as well. Now we'll give upload success. The paragraph tag will that's equal to the color green as green. We'll write in this as I uploaded successfully. Now let's get the upload button with dynamic label. So we'll just give a tag here as button. Click handle upload. Then disable, that's equal to the selected size. Selected size. Then is uploading pending, and is upload confirming. We don't close it here. Now this will write. Now we'll give is uploading, and we'll give the text as uploading to IPFS. So this text would be shown when the file has been uploaded to IPFS and is in progress. Then and this file will be taken from is upload pending. So this will be taken from is upload pending. Then we will display another text that is of confirming transaction. So we'll write as confirm transaction. So this text will be shown once the uploaded files transaction is all completed. And this will be taken from is upload confirming. So is upload confirming. And then we'll just display confirming. So confirming. And now we'll just upload the file, and we'll just close our button tab here, and also our division. And I'll just give a divider line, that's our horizontal line. Now we'll give a section for displaying the user's uploaded files. So division, and in our H2 forms, we'll just mention first your files, and in this we'll have all the user files dot length, and then we'll just close it here. So now this title will be shown, showing all the number of uploaded files by the user. Now we'll give the condition to it. User files dot is equal to 0. This will check if the user file length is 0, that no files are uploaded. Then if this happens, then it will show a text to the user as no files uploaded yet. So we'll just give it in a paragraph tag as no files uploaded yet. Now we'll just give the link to open the file on public IPFS gateway. So for that, we'll just give RA tag, and inside that we'll give our href, and here in this we'll give our Pinata gateway. So I'll just mention Pinata gateway slash IPFS slash and then file.ipfs hash in it. Then we'll just give the targets. So targets that would be equal to blank. So this will be opening it in a new tab. And this Pinata gateway is like building a URL to open via the gateway. Then we'll give RAL and then we'll give it as no opener, no referrer. So this is like for safety, no referrer. And then here we'll close the stack. And then inside this we'll give view file. So it will just click to view file on IPFS. If we click it, this all will be displayed. And then we'll just close the stack now. And now we'll just delete the uploaded files. For that, for deleting the uploaded files, we'll give the button tag now, button. And inside this, now we'll write on click. On click, that would be equal to the handle delete. So this will call the delete handle. So I will write handle delete and the index. So it will call the delete handle with the file index, and I will just disable equal to is delete pending, and is delete confirming. So this will disable the buttons during the delete action. So we'll just close our button tag, and inside this we'll now write delete. So we can just this is just a button text, so delete will be displayed. So this was all about the front end. Now let's go on creating our .env file. So let's create a file and name it as .env. Now in this .env file, we'll write our public, our Pinata API key, our Pinata secret key, and our Pinata gateway. So first we'll write the text and then we'll understand how to get our API keys, Pinata API key and Pinata secret key. So we'll just write the text here first in your .env file. So next underscore public Pinata key, and we just have to paste our actual API Pinata key here. Similarly, we have to write for our Pinata secret key, Pinata public secret. Also, we have to mention the public Pinata gateway. Here we'll give our Pinata gateway, which is the link to the gateway of Pinata cloud. So we'll just mention it here, and gateway.pinata. Now we'll just open git bash in our terminal. Now we'll give the command as cd frontend, and now we'll go on exporting our private key. So we'll give the command as export private key, and here you just have to enter your private key. As is confidential, I won't enter my private key here. And now I'll give the command as npm run dev. So now it will just provide us the link. So okay, so here we can see in local, we can see the localhost 3000. So once we click the link, so once we click on the website, we'll just go on connecting the wallet, and I'll just click on MetaMask. So the MetaMask window will pop up here. I'll just click on connect. So
it will connect the MetaMask wallet to the IPFS. Now I'll just upload my file to IPFS. I'll just randomly choose one file, and now just lower clicking upload to IPFS and blockchain. So it will just upload it. And now on this MetaMask, I'll go on confirming all the transaction requests. And once I've confirmed everything, it will go on confirming the transaction. And here you can see on this side, we have all the text like why choose our DApp and everything been mentioned on this front end. Also, there is a section of your files where you can just see all the uploaded files. Now, I haven't seen it. There are no files uploaded yet. So once you upload it, the file can be seen there. I'll just check my transaction status. Go to MetaMask, where it's showing that contract interaction is still pending. So we'll wait till the time it gets confirmed. So it's still confirming the transaction. Oh yeah, so here we see the upload is successful, and we can even click on upload another file. That was all about the video. Thank you.